Welcome back to Bavarian RC. In today's video, I'll present to you the Airtrainer 140 from Robbe Modellsport. The Airtrainer is a P&P model that only needs a few assembly steps before the first flight. It comes with all the electronics installed, except the receiver and the battery. It has a wingspan of 1.4 meters and an all-up weight of around 1500 grams. The Airtrainer aims at RC pilots that have already some basic 3-channel experience and want to step up to the next level, including some aerobatics. To assist the pilot, it has a flight controller with a 3-axis gyro and 2 different modes. The level mode for beginners is keeping the plane always within a safe envelope and returning it to level flight when the stick is released. The stabilization mode is giving you full control of the plane, while the flight controller is stabilizing it and minimizing the effect of wind or gusts. Check out the description below for all of the detailed specs. In the first part of the video, I'll guide you through the assembly process and the small modifications I made. In the second part, I'll put the Airtrainer to the test and see what it can do when released into the air. Now, let's see what's in the box. The instructions are nicely done and contain 3 languages: German, English and French. There's a list of replacement parts, an overview of all the parts in the kit, and a step-by-step description of all the assembly steps. In my case, the instructions were sometimes slightly differing from the kit, but this was not a problem. I'll tell you in more detail during the assembly. The 2-piece wing has a very clean and hard surface, with all the decals already applied. The servos are already installed and the pushrods connected to the ailerons. These are 9-gram plastic gear digital servos. The clevises are made from plastic. I might replace them with metal clevises to be more on the safe side, but that's my personal preference. The ailerons run very cleanly in a fillet. Now that's really nice. At the wing root, you have the servo connector for the aileron and the connector for the LED at the wingtip. The control horn is screwed through the aileron into a counterplate. That looks really solid. The rudder uses the same type of control horns. On the underside, we have a plastic part for attaching the stabilizer to the fuselage. At the bottom of the rudder, there's another plastic part that connects the rudder to the steerable tail wheel. The 2 sides of the elevator are linked by a U-shaped steel wire. In the center, there are 2 plastic inserts for the attachment screws. The horizontal stabilizer doesn't have a spar, but is still quite strong. Let's check out the fuselage. The motor is already installed. In case of need, the motor cowling, which is held by 2 screws, could be removed to gain access to the motor mount. The battery hatch is on the underside. To access the battery compartment, you need to disengage the latch and press both tabs together simultaneously. The battery is secured with Velcro tape and connected via the XT60 connector. The ESC is located above the battery compartment and already connected to the motor. The first thing you notice in the electronics bay is the flight controller. The wires are all nicely labeled and I'm already curious about the features of this flight controller. Below we have the 17-gram plastic gear servos for the elevator and the rudder. The pushrods are already connected to the servo horns, so only very few things to do in this area. The steerable tail wheel will be directly connected to the rudder. Here we see the mounting slot for the vertical stabilizer, which will be held by 2 screws. The pushrods for elevator and rudder are ready for being connected. The massive 12 by 8 inch prop is covered by a painted foam spinner. The landing gear consists of 2 aluminum legs and lightweight foam tires. There's just a small bag of accessories which contains the screws for mounting the wings, 2 screws for the stabilizers, 4 small screws for the landing gear, a Y cable for the LEDs, spare clevises, the mounting brackets for the wing, and a plywood wing joiner. Did I forget anything? Oh yes, the carbon tube main spar for the wing. Now let's assemble the Airtrainer 140. In the end, it took me only about 1 hour to complete the assembly and programming of the air trainer. So this is really a quick and easy build. Now let's get out of the hangar and into the air. For the first flights, the weather was quite windy and my runway obviously quite narrow. So I was really curious to see how the air trainer would handle these conditions. My concerns about the windy conditions were totally unnecessary. The air trainer flew like it was running on rails. The overall handling is ideal for pilots that are still on the learning curve and want to step up from basic 3-channel flying to some aerobatics. The air trainer is capable of basic aerobatics like looping, roll or turn. Flying inverted requires a very small amount of down elevator whereas Knife Edge requires a significant amount of aileron and elevator correction to keep it straight. With a 3-cell LiPo, the plane is very well powered, but it will not go vertical. Maybe at a later stage I will test it with a 4-cell battery. The motor and the ESC could handle it. The battery compartment would need some reconfiguration to have enough space for a 4S LiPo. Landing is not critical at all. Just come in with a bit of power applied, bleed off some airspeed, and then cut the power completely at the very last moment before touchdown. As you could see, I landed the air trainer on grass instead of the road. Well, to be honest, I tried hitting the road, but after the first less successful attempt, I decided to better use the meadow. To be clear, this meadow is far from being a well-cut grass strip. Nevertheless, the landing gear of the air trainer had no issues with all the bumps. All in all, the forgiving flight characteristics, the stabilization mode of the flight controller, and the rugged design together with the easy assembly makes the air trainer a perfect model for a beginner looking for his second or third plane. There is enough potential in this model for letting a beginner pilot grow from basic 3-channel flying into aerobatics and having a lot of fun on the way. Technically, there are only a few little things that could be improved. First, let's talk about the landing gear. I have to admit that my first 1 or 2 landings were not too smooth, and the landing gear got slightly bent. Repairing it was not a big deal, and actually it was not the landing gear that was bent, but the screw that was serving as an axle for the wheel. It seems that the material is quite soft. I replaced it with a higher quality screw. Speaking about screws, the head of the original attachment screws got quickly worn out. I replaced them with hexagon socket screws. The space for the receiver and the flight controller is pretty small. With all the wires running around here, it is sometimes a challenge to get the wing mounted without squeezing at least one of the wires. Well, another thing is the battery tray. A 2300 mAh 3-cell battery just about fits in, and the hatch already bulges a bit. There would be plenty of space that is unused just above the tray and the plywood support. And of course, installing a battery through a hatch on the underside is always a bit annoying. So nothing really severe. All the rest of the design works super well, and you really get a lot of value for your money. This plane is just 229 euros and it comes with a motor, the ESC, the servos and a flight controller. As said before, all you need to add is a receiver and a battery. If you liked my onboard video footage and also want to attach an action camera to your air trainer, then check out how I made my custom camera mount. I created 2 different mounts for the Insta360 Go 2, one on top of the wing center and one at the wingtip. The center mount consists of a 3D printed support that is attached with spacers and M4 screws utilizing the standard wing attachment. The link to my free STL files is in the video description below. The small size and weight of the Go 2 makes it ideal for attaching it to the wingtip. Again, I'm using a 3D printed support. To secure it in place at the leading edge, I used a 1mm steel wire that runs in a short piece of tube. In addition, I used several strips of tape to hold it firmly to the wing surface. Of course, you need to add a balance weight to the other side. In case you have a different action camera, you can easily adapt my design, for example for a GoPro mount. I hope you liked this video. If yes, please give me a like and also consider subscribing to my channel. This will help me a lot to continue providing more content for you. Thanks for watching Bavarian RC.